Madam,
Sir, just wait for two minutes, sir.
okay.
Sir, you can start your lecture. Sorry for disturbance, sir.
Yes, ma'am. Yes. Now these are the steps involved in HPTLC analysis. That means for any qualitative or quantitative analysis of herbal constituent, by either qualitative or quantitative, there should be one standard and sample. We have to analyze qualitatively and quantitatively the sample provided, whether that active constituent are present in or not. And if the active constituent are present in sample, then how much it? That means standard should be there. Standard means that the marker compounds are those compounds which are mainly active components and which are very stable. So this standard or marker compound should be there for HPTLC analysis, because we have to compare the standard data with sample one, and then we can analyze. Therefore, sample and standard of preparation and selection of chromatographic layer. We can apply the proper amount of concentration of that sample and standard one on pre-coated aluminum silica J60 to 54 plate with the help of illuminate applicator. And after some period, after activation, we can place that plate at an 45 angle into interrupt chamber where already or previously the mobile phase is saturated. In chromatographic development, that means method development and validation. So we have to develop proper mobile phase. Which mobile phase required, that is depend upon your trial and error method or whatever that triangle given in the book of TLC Stahl thin layer chromatography book, depending upon the polarity and non-polarity, depending upon the nature of secondary metabolite or active chemical constituent which has to be separated, we have to use the proper amount of mobile phase. In general, at first 90 methanol and 10 water, that is 90-10 methanol water should be used, and then we have to try it by using the different solvent of different polarities and different ratio. We can go for trial and error method, and that mobile phase should be saturated for 20 minutes into trap chamber. After saturation, then place that mobile pre-coated aluminum silica plate at an 45 angle in that twin trap chamber, allow to run that mobile phase in ascending order, and after some time remove it and detect the spot. If the spots are available, no problem. If the spots are unavailable, you can use the derivatization agent or visualizing agent or any spray particular for a detection of spot. And before that, you can place that plate for scanning, where actually scanning or documentation of that chromatographic plate can be done. So this is the TLC scanner, and majority it is used for quantitative analysis, rather than qualitative. No doubt, qualitative and quantitative analysis can be done by TSC scanner because it is scanner. Its cost is very high. Instead of TSC scanner, another is smart DG or photo visualizer. We can use for qualitative analysis, that is only for calculation of RF value. We can get the RF value, that is the qualitative analysis, and optimize the oval phase. We can get the separation of colored bands. But you should have a scanner for quantitative analysis. Once you place that plate in a TSC scanner, then there will be the densitometric scanning. So quantitative evaluation with CAMAC TSC scanner 3 or 4. Vision CAT software. It is software and cost of that software is more than 10 to 15 lakh. Total cost of HPTS instrument is about 40 lakh, including TSC scanner. Without TSC scanner, you can get it up to 15 to 18 lakh rupees. That is Vision CAT software is the best which control the TSC scanner 4 and enable the quantitative evaluation of the generated densitometric data. So this word is important, densitometric scanning. At this stage, when you place your plate in that TSC scanner, then there are the detectors, UV detectors that UV rays can be treated with that spot or extract, and densitometric scanning takes place here. That means what you have actually studied in case of UV spectroscopy, ultraviolet spectroscopy, whenever you analyze your sample by UV, then in case of UV, the same sample can be done by UV, IR, NMR, mass, but in case of UV, what happens? There is electronic transitions. Sigma transitions, sigma bonds, pi bonds are there, pi electrons are there. Therefore, N to pi transitions, sigma to sigma star transitions. Yeah, so all these such a type of transitions can take place, and therefore you can get that electrical signal that is converted into spectra after densitometric scanning. So densitometric scanning can be done only by TSC scanner. Without TSC scanner, it's impossible to get densitometric scanning. The spectral range of light from 190 to 900 nanometer is available for selecting single wavelength for scanning densitometry. Detection can thus fine-tune to match the spectral property of the analyte to its optimized specificity and sensitivity. And therefore, before and after delimitation can be, you can use the each scanning step may also be include multi-wavelength scanning using deuterium lamp, mercury lamp, tungsten lamps are there. So the detection modes, that is absorbance or fluorescence, can be combined. The generated data can then be evaluated, and integration of peaks and assignment to the separated substance is a matter of this phenomenon. So you can do this densitometer scanning work by TSC scanner. So it is just a schematic procedure for HPTSC method development, that is sample and standard preparation. In any case of analysis, we should have one sample and standard. We have to prepare a proper amount of solution for application. Then a selection of chromatographic layer pre-washing, layer pre-conditioning. For this, pre-coated aluminum pre-coated sigma pre-coated aluminum silica gel 60 to 54s are available, and you can apply our spot of sample and standard one with the help of this Lunomat applicator. After application of spot, remove that plate, place that plate in this twin trap chamber, just like in case of TLC, and allow to run that mobile phase in an ascending order, place that plate at a 45 angle, and after some time, you can remove that plate, dry it, you can get the spot, you can detect the spot, you can go for scanning in previously described in TSC scanner, and then you can get the photo documentation here. So this is in general schematic procedure for HPTSC method development. Method development, that means what? We have to develop, that means we can get exact peak. If there are several constituents in only one extract, and if there are several constituents in only one extract, then we can get exact peak. If there are several constituents in only one extract, then we can get exact peak. If there are several constituents in only one extract, then we can get exact peak. And whatever you are using that mobile phase, if that appropriate mobile phase is applicable only two spot, then you can get only the two peaks. That means in one spot, if there are several constituent, you can get the separation of two phytochemical constituent and two peaks you can observe. That peak should be sharp. Also, you can get the fingerprint if you are using TLC scanner. That is the method development. And just like method development and validation, if you have developed a method, that is means if you have developed a proper mobile phase, optimize the mobile phase, then the developed method is correct or not, that you can validate by using certain 8 to 10 validation parameters. Just like in case of HPLC, you are using linearity, LOD, LOQ, accuracy, specificity, robustness, ruggedness. All these parameters precision can be done for HPLC validation, HPLC method development and validation. So in plates, generally the plates which are used in HPLC analysis are 20 to 20 centimeter or 5 to 7.5 centimeter size and having 100 to 250 millimeter adsorbent thickness. In general, most preferably silica gel 60F fluorescent 254, that is the nanometer wavelength at 254 fluorescent. So this is one branded produced by Sigma silica gel 60F to 54 plates of high resolution are generally used for HPLC analysis. Then deuterium chambers are totally different from our glass chamber. That means these are very sophisticated. There is an internal arrangement or structure where we can place your plate system in this at an 45 angle. You can allow your mobile phase to run in ascending order. Then the spot contain several active constituent, so that active constituent from that spot can be separated when your mobile phase is run in an ascending order, and you can get such spot on this plate after some time, maybe after 10 or 15 minutes. So that is development of chromatogram. Now remove that plates. If it is visualized, no doubt. If they are not visualized, you can using by spraying agent or visualizing agent or proper detecting agent. You can spray it, then you can get the colored spot on your plate. If you visualize that plates in photo visualizer in HPLC system, you can get the colored bands, such like. If you apply here a marker compound and here one is sample and sample, sample 1, sample 2, then the separation of marker can be done and you can compare the RF value of that marker compound with the RF value of that separated phytoconstituent in that sample 1. Now factors affecting RF value, this retention factor. See here, in case of UV, IR, NMR, HPLC, HPLC, there are different shapes of peaks. In case of UV, you can observe just like a bell-shaped curve. In case of IR, there are downward peaks. In case of NMR and mass, there are bars. In case of HPLC and HPLC, on x-axis there is RT. In case of HPLC, in case of HPLC, on x-axis on graph there is RF retention factor. On y-axis there is area under curve, as in case of HPLC, same is as a case of HPLC. So RF retention factor of that particular marker at a specific point, that depend upon the nature of adsorbent, mobile phase, activity, thickness of layer, temperature, equilibrium, loading, size loading spot, dipping zone, and chromatographical technique. All these are the factors which are responsible for RF value. If you can change the mobile phase, you can change RF value. That means you can get different RF value. So depending upon the proper mobile phase and proper proportion of that mobile phase system, you can get the appropriate RF value. Now up to RF value, that is the qualitative evaluation. In scanning and documentation, scanning is generally done by densitometer scanning by using TLC scanner 3 or 4. That is quantitative analysis. HPLC plates are scanned at selected UV region by that instrument. and you can get the spot which are seen on computer in the form of pics. The scanner convert band into pics. What happens here? TLC scanner 3 or 4 version, that scanner after the densitometric scanning of that spot, that scanner convert bands of that plates, bands which are observed on that plant, that band can be converted into peaks, and peak height or area is related to the concentration of the substance on the spot. See here, that is the mechanism. Now, there are some of the typical examples, that is separation of some of the, actually previously, some of the allopathic medicines can be done, separation and active identification of that allopathic medicines can be done by using HPTLC here. So this is the UV spectra of sulfonamide, sulfamethoxazole maximum 308, sulfamerazine maximum, वगैरह वगैरह, all that means multi-wavelength scan for evaluation of the optimum wavelength for each compound can be done. So these are the typical examples, but mainly HPTS is mainly proper for herbal analysis. For example, you can see here Rauwolfia serpentina serpagandha extract. As you know, Rauwolfia serpagandha contain indole type of alkaloids. So there are Rauwolfia contains rauwolfinin, reserpine, deserpidine, ajmalicin, serpentinine. All these are the chemical constituents. So all these chemical constituents are very important medicinal therapeutic active components, and these are present in genuine Rauwolfia root. The Rauwolfia root genuine drug can be adulterated. And as a part of analyst, as a part of pharmacognosist, you have to analyze in herbal industry that Rauwolfia is a genuine or adulterated. And correct identification of Rauwolfia serpentina can be done by using only and only HPTLC. If you take the extract of Rauwolfia and you can apply the extract on your plate with the help of a linomet applicator, that spot can be separated by using mobile phase system, and that spot, subject that spot and application system to the densitometer scanning by TLC scanner, you can get the pics or fingerprint like this on your computer. That means the separated bands are converted into the pics. Pick number 1, 2, 3, 4, 5 like that. So this is one with the fingerprint of that Rauwolfia root extract, and that can be done only and only by high performance thin layer chromatography. For example, gingiber officinale, ale, it contains gingiber and gingerol as the active constituent. So you can apply 1 or 2 marker compounds, spot of marker compounds or standard on your plate at the baseline here. This is the 8 millimeter length width of that spot by linomet applicator. You can apply it. You can apply the again sample spot on this side at the baseline, and you can compare the data of standard with sample one. So whatever in development of chromatograph, the phytoconstituents can be separated, that marker compounds can go ahead in ascending order and can adsorb at particular spot. That's called as the RF value. So you can compare that RF marker compound with RF of your phytonutrients which are present in your sample. So such a type of color bands you can visualize on your plate. You can take it photo documentation system, you can visualize it by visualizer, and you can go for subject this plate by densitometric scanning. That means ultraviolet rays or any type of that light which is available in that particular system that can treat with this band or spot or extract spot, and through densitometric scanning, electronic transition scans takes place, and that band can be converted into the pics. So you can get that pics, you can visualize such a pic system on your monitor computer system. So quantification of thymol in Trachispermum amni. Thymol is present in certain 2 or 3 plants, but in case of Trachispermum amni, you can identify qualitatively or quantitatively thymol. So all these are the bands which are, when you apply the spot On one side, your spot or markers, on another side, your herbal extract sample allowed to run through mobile phase system. So there is a separation of bands, and exactly whenever the thymol adsorb, it can adsorb at the particular site. So you can calculate that value solute front divided by solvent front. You can get the RF value. Ultimately, there is a system or provision in that software system. You can put this slide in that chamber. You can get observe that peaks, and you can get ultimately that RF values. Also, by manually also we can calculate that RF values. You can compare the values of these marker compounds with the separation of separated phytoconstituents in herbal extract, and you can compare with that library data. So quantification can be done of different herbal species by using HPTLs. So this one is the best example. You can get such a fingerprint on your computer or monitor. If that touches for example, that herbal extract contain 7 to 8 chemical constituent, then that 7 to 8 chemical constituent can be separated by proper mobile phase system. You can get 7 to 8 bands. That bands get be converted into peaks with the help of densitometric scanning, and you can get one of the peak of thymol here. You can compare the peak of thymol with the standard one. In case of standard sample, you can get only one peak, but whenever you can analyze it of your sample, that sample gives rise to many peaks. So by comparing the one peak of thymol of standard, you can compare with that the thymol present in your herbal extract. For example, fingerprinting of combiphora wheat, a raw material with formulation. Google. So such a typical example, your drug may be Ayurvedic, Siddha, Unani, homeopathic, whatever may be that plant. Plant contain extractive material, and different type of plant material contain different type of secondary metabolites. That secondary metabolites may be alkaloid, glycoside, resin, tannin. So depending upon the nature of secondary metabolites, you have to use the proper method of extraction. Sometimes ethanolic extract may contain alkaloid, methanolic extract may contain alkaloid, but water extract may not be contain alkaloids. That means depending upon the proper system of extraction, you can get the isolation of phytoconstituent, and whatever you want that you can separate qualitatively. You can identify quantitative estimation you can done by densitometer scanning, and just like this is the method, you can apply the spot here with applicator, allowed to run into a trap chamber, remove that plate, visualize in photo visualizer. You can observe the color bands, and if you want to quantitative estimation, put that plate in a TLC scanner. In TLC scanner, what happens? That rays can treat with all these spot and bands, and that bands are ultimately converted into peaks with the help of densitometric scanning through electronic transitions of that structure of that phytoconstituent present in that extract. For example, ginseng. Ginseng contain various type of glycosides, ginesoside. So all these estimation, qualitative and quantitative analysis is already done in Ankrom laboratory. Ankrom laboratory, Mulund is a very popular laboratory where different type of analysts, they research projects, MPharm student, PhD students, some of the co-investigator, principal investigators, they can do their analytical work on HPTLC qualitative and quantitatively in Ankrom laboratory. Also, our college is also having HPTLC for qualitative analysis. We can go for qualitative analysis, separation of bands, separation of peaks, and we can provide you the RF value and separation of band photo estimation. Whatever we can get, we can provide you all that qualitative estimation, and quantitative estimation with the help of TLC scanner can be done in Ankrom lab, Mumbai. So whatever be your sample, you can analyze it by qualitative and quantitatively. Now HPTLC applications, mainly HPTLC is used for pharmaceutical research. In pharmaceutical research, that means in herbal industry mainly, and in many of the allopathic industries also, if they have their herbal unit or herbal component, if there are small or large units, if there is any medicament, then separation of that active pharma phytochemical constituent, and their identification can be done in case of pharmaceutical research by using HPLC. In biomedical analysis, it is mainly preferred. So in clinical analysis, in environmental analysis, it is also mainly preferred. Majority of the HPLC is used in food industry because therapeutic drug monitoring TDM is required to determine the concentration and metabolite in blood urine level. So we are always eating that food material, nutraceutical, dietary supplement. So there should be therapeutic role of that nutraceutical. If there is any impurities, so it may cause a dangerous and toxic impurity in our body. So for identification of the best food product, HPLC analysis is better, and it is mainly used by food industry also. In qualitative and quantitative determination of phytoconstituent in herbal extract, in many of the herbal industries like Himalaya, Dabur, Charak, Bajjana, Jandu, all these major players in India, they are using this HPLC. Many of the research organizations, central government organization, Ayush government, ICMR, all that mainly research organizations, they are using high performance thin layer chromatography for correct identification of phytoconstituents, for identification of genuine drug. So in pharmaceutical industry, in quality control department, to identify checking the purity, content uniformity in pharma industry, it is mainly preferred. In food analysis, in clinical application, in metabolic study, drug screening, stability in food analysis, in QC additive pesticide stability testing department in food analysis. As an industrial application of HPLC in process development and optimization, in forensic department for poisoning investigations, HPLC is playing a main role for correct identification of your marker compounds or correct identification of active pharmaceutical ingredient in final pharmaceutical dosage form or herbal dosage form. Okay, now thank you. If any question arises, all the participants, you can ask me any questions or any doubt about HPLC. Thank you once again.
Yes, participants, if you have any question, you write it on YouTube live chat.
Thank you so much, sir. Such a great informative session.
Bharti
Thank
ma'am,
you so much, sir.
wait. Bharti ma'am, wait.
Okay, ma'am. Okay.
Is having any doubt or any query about HPLC, qualitative or quantitative estimation of phytonutrients, phytoconstituent? You can ask freely. Yes, ma'am.
Wait, sir. I think stream is stopped.
Yes. That's okay. I'm very much thankful for Dr. Nitya Moire sir and Sanap ma'am for giving an opportunity to deliver my presentation of HPLC analysis work. And also,
Sir, the stream is started, but no one asked any question. So
okay.
I request Jyoti Sonone ma'am to give a vote of thanks.
Okay, okay. Thank you, madam. Thank you once again. Thank you.
I request Prajakta Subramani ma'am to give a vote of thanks.
Thank you very much. Thank you.
Good afternoon, everyone. It has been such an honor to be a part of this wonderful session. On behalf of organization, I would like to extend my heartfelt gratitude to our esteemed guests. Sincere thanks to our guests who worked on their respective area and topic for very long time to develop novel ideas and findings. So our today's topic was development and standardization of herbal formulations. So Dr. V.R. Sarunke sir, Professor and HOD of Rajaram Bapu College of Pharmacy, Kasegaon, Sangli. Sir delivered very informative session about HPTLC and taken in depth qualitative as well as quantitative analysis how it can be done with HPTLC, development and standardization of herbal formulation using the different spectrophotometric instruments, how it can be done and what are their limitations of different instruments as compared to CAMAG TLC scanner, HPTLC scanner. Different types of herbal formulations. We can also find out adulterated compounds easily by HPTLC, on which Sir explained so many plant examples. We are routinely working, but did not think those things that much in depth. Sir also explained applications of HPTLC rather than pharma industries. Very good, very informative session, sir. Thank you so much.
Thank you, ma'am. Thank you, all of you.
I would like to thank Principal of our college, Dr. Nitin Moire sir, and organizer, Professor Manjusha Sanap, Ganeshmal Chaudhary sir, and all organizing committee for arranging FDP on applications and informative sessions. Thanks to participants present on YouTube live stream for making the time to be with us. Thank you.
Thank you, ma'am.
Okay, now I request Jyoti Sonone ma'am to introduce our next speaker.
Good morning, all of you. Now, I welcome our second speaker, Professor Manjusha Sanap ma'am, who is working as a assistant professor in Shivajirao S. Zondale College of Pharmacy, Asanrao. Ma'am had completed her M.Pharm from Pravara College of Pharmacy, Loni. Ma'am having 11.5 years experience in academics. She worked as exam in charge, coordinator in seminars, and coordinator in various social activities. Worked as an external and internal examiner, paper setter. This is about academic experience. I would like to share many things about ma'am academic achievements. Ma'am has published 11 national and international research papers. Ma'am has presented 6 papers on national and international levels. Ma'am has about attended more than 20 conference and seminar. On final note, I would like to say we are very grateful for this presence among us today. Now, Manjusha Sanat ma'am, I request you to start your session. Thank you.
Good morning to everyone. Today I deliver my lecture on hyphenated technique. I thankful to our principal sir to give an opportunity to speak on today's FDP. Thank you, sir. Now I start my session. So hyphenated techniques. Hyphenated techniques are those analytical techniques in which chromatographic technique and spectroscopic technique are coupled for analysis of various biological, chemical, and toxicological samples. Hyphenated technique is a combination or coupling of two analytical techniques with the help of proper interface. So, in hyphenated techniques, the separation technique and the spectroscopic techniques, they are coupled with interface. And the day by day, there is a modification in this technique and it is used for analysis of various biological, toxicological compounds such as proteins, immunogens, drugs, poisons, adulterants, toxins, and dyes, etc. The term hyphenation was first adopted by Hirschfeld in 1980 to refer the combination of separation technique and one or more spectroscopic detection techniques. The aim of coupling is to obtain an information based detection for both identification and quantification. So these hyphenated techniques are mainly means they are introduced for identification and quantification purpose. Now the advantages of these hyphenated techniques, it is for fast and accurate analysis, a high degree of automation, means these hyphenated techniques are fully automated techniques, high sample throughput, better reproducibility, reduction of contamination due to its closed system, and separation and quantification at the same time. Means in chromatography we can separate the technique, we can separate the compound, and then we analyze the compound by using different detectors. And in spectroscopy we can only detect or quantify the compound. So in hyphenated techniques, both separation as well as quantification is done at the same time. So these are the advantages of hyphenated techniques. Now there are different types of hyphenated techniques, that is double hyphenated techniques and triple hyphenated techniques. Means double hyphenated technique means in which one is separation technique and another is spectroscopic technique. One is separation technique and another is spectroscopic techniques. And in triple hyphenated technique, the one or two separation technique or one or two spectroscopic techniques are used. So double hyphenated techniques are like LCMS, NMR, means LCMS means a liquid chromatography, means mainly used liquid chromatography is HPLC. HPLC is coupled with mass spectroscopy. Then LCNMR, in LCNMR also HPLC coupled with NMR. Then LCIR, so HPLC coupled with IR spectroscopy. Then CEMS, that is capillary electrophoresis, it is used as a separation technique, and mass spectroscopy, it is for as a spectroscopy technique. Then GCIR, the gas chromatography coupled with IR spectroscopy. GCMS, HPLC, DAD, that is HPLC, it is a separation technique, and diode array detector, it is the detector technique or spectroscopic technique. Then GCFTR, these are the double hyphenated techniques. And then triple hyphenated techniques means there is a combination of three techniques. So like LC API MS, then APCI MSMS, then ESI MSMS, then LC ESI MSMS, LC UV NMR. Then also it is there is a merging of two different techniques like MS and ESI. ESI, it is a part of MS system, mass spectroscopic system. It is a mass analyzer used in mass spectrometry. APCI, it is also a part of mass spectroscopy. LC-NMR MS, LC-DAD, API MS, LC-PDA MS, okay, LC-PDA NMR. So these this triple hyphenated techniques or the hyphenation of two or more techniques, they are generally used for higher quantification, for higher separation as well as for higher quantification. So this hyphenation does not always have to be between two techniques. There is a coupling of separation and detection techniques can involve more than one separation or one detection technique, like LC-PDA MS. So liquid chromatography, photodiode array detector, and mass spectroscopy. So LC, it is the separation technique. PDA and MS, these are the detector techniques. Then LC-MSMS. So that is liquid chromatography, they coupled with tandem mass spectrometry. MSMS, it is called as a tandem mass spectrometry. So the two mass spectroscopy, they are coupled with LC. Then LC-NMR MS. Then LCTDA, liquid chromatography, photodiode detector, NMR and mass. All these are coupled. Means always in hyphenation, not only two techniques are coupled, more than two techniques are also coupled. Okay. Whereas in trace analysis, there is the coupling of solid phase extraction. Okay. As well as solid phase micro extraction or large volume injection with the spectroscopic technique. Example SPLCMS means solid phase extraction, liquid chromatography, and mass spectroscopy means for the trace analysis. Then LVI, large volume injection, GC, and MS. So first of all, we start with GCMS. GCMS and LCMS are more commonly used hyphenated techniques. So GCMS is composed of, means it is the combine the features of gas chromatography and mass spectroscopy to identify the different substances in the test sample. The GCMS instrument or it is a combination of or coupling of two features, gas chromatography and mass spectrometry. So GCMS separates the chemical mixture into individual components and then identifies or quantifies the components at molecular level. Means either they determine their molecular weight or they determine their structure by using mass spectroscopy. It is one of the most accurate and efficient tool for analyzing volatile organic samples. It is one of the most accurate and efficient tool for analyzing volatile organic compounds. And this it is done by calculating the molecular weight and structure of both organic as well as inorganic compounds. And as well as identification of analyte in the complex mixture. In GCMS, what is the principle of GCMS is in GCMS instrument, it separates the chemical mixture and identifies the components at molecular level. GCMS work on the principle that the molecules are retained by the capillary column. The molecules are retained by the capillary column at different times. Then the mass spectrometer, they capture the molecules. Then they ionize it, accelerate it, deflect and detect the ionized molecule, separated by the breaking each molecule into ionizing fragments. And then that fragments are detected, and it is their mass to charge ratio is detected, and then we can identify the compound. So the principle of GCMS, so the molecules are separated by capillary column. Then it is eluted from column at different types towards the mass spectrometer. And then in mass spectrometer, that molecules are captured, they get ionized, they get accelerated, deflected, and then it is ionized. That molecules are ionized, and that ionized fragments are then detected according to their mass to charge ratio. See, this is the block diagram of GCMS, gas chromatography coupled with mass spectrometry. In gas chromatography, it separates the mixture of components in individual. Please wait for some time because there is a network issue.
Madam, your slide is not visible. तुम slide नहीं दिखा. Hello. YouTube ला.
Yes, sir. Wait, sir.
Okay. Yes, madam, your slide is visible now.
Okay. Now it is visible.
Yes, ma'am.
So this is a block diagram of gas chromatography mass spectroscopy hyphenated techniques. In gas chromatography, there is a separation of mixture of components into individual components. And in mass spectrometry, it identifies the molecule based on their mass to charge ratio. And GCMS, it is a chemical analysis technique. They combining these two instruments to provide the powerful separation and identification. This is the instrumentation of GCMS. So means the regular requirement of gas chromatography, it requires the carrier gas, then flow regulators, pressure regulators, and the column oven. So these are regular requirement of gas chromatography. Then one there is a transfer line, heated transfer line is between the gas chromatography and mass spectrophotometry. There is one here heated transfer line, or it is also called as the interface. Interface used between the GC and MS. So in mass spectrophotometer,
that the separated components are they enter into the mass spectrometry, and here then further they get ionized, then they accelerated, and they are detected according to their mass to charge ratio. So this is the instrumentation or the block diagram of the instrument of GCMS. Now, what are the working steps of GCMS? So the sample they first introduce into the GC, then the sample components, the analysis separated by their differences, partitioning between the mobile phase and liquid stationary phase. Because gas chromatography, it is classified into two different types: gas solid chromatography and gas liquid chromatography. But the mostly used technique is gas liquid chromatography. So in gas liquid chromatography, both the mobile phase as well as the mobile phase is carrier gas because it is a gas chromatography, and there is a liquid stationary phase. So that liquid stationary phase, it is held on the column. So there is a partitioning between the analyte is separated according to their partitioning between the mobile phase and liquid stationary phase. So they are separated. So after their separation, the neutral molecule means that molecule is heated per line. So after the separation, the molecules are eluted through a heated transfer line into the mass spectrometer. So within the mass spectrometer, the molecules are first ionized and most of by mass ionizer. So the mass ionizer are used to ionize the molecule. Okay. So generally used mass ionizer is electron ionization and chemical ionization techniques. So these are the mass ionization techniques. So by this mass ionization techniques, the molecules are get ionized, and the next step is to separate the ions of different masses according to their mass to charge ratio. Means that the ions are separated according to their mass to charge ratio, and then it is detected by the mass analyzer. The most commonly used mass analyzer in GCMS, it is TOF, that is time of flight mass analyzer. So this is the working of GCMS. Now the next hyphenated technique is LCMS. The next hyphenated technique is LCMS. So like GCMS, I already explained that GCMS and LCMS are the most commonly used hyphenated techniques for better separation and better identification. So LCMS, they combining the separating power of high performance liquid chromatography with the detection power of mass spectrometry. Liquid chromatography separates the component using stationary phase and mobile phase. So liquid chromatography, here they follow the adsorption. So they separate the component according to solid stationary phase and liquid mobile phase. Then mass spectrometry measures the mass to charge ratio of that charged particles. Liquid chromatography mass spectrometry is the technique which performs the separation by liquid chromatography and mass analysis with the help of mass spectrometry. The electrospray needle is used to bridge to connect the liquid chromatography with that of mass spectroscopy. Means interface is used to connect the chromatography with the spectrometry. So there are three main components of LCMS are chromatograph, that is chromatography, that is HPLC system. In liquid chromatography, separation is performed, which is detected with the help of photodiode array. This separated component then transferred to interface. In interface, the liquid is volatilized and transferred to mass spectroscopy. Because in mass spectroscopy, the sample must be required in ionized form. Because in mass spectroscopy, the sample must be required in ionized form. So this interface is required in between this LC and MS. Because in liquid chromatography, the sample is separated in the form of liquid or in the form of solid. So it is converted into their ionized form by using interface. And in spectrometry, with the help of various ionization techniques, the compound is get ionized and then it is analyzed by using different mass analyzer. So this is the instrumentation of LCMS. This is the instrumentation of LCMS. So here it is the HPLC system with solvent reservoir system. These are the pumps to regulate the pressure as well as to regulate the flow of the mobile phase. Then it is the sample injector system, then column, and after the column, it goes towards the mass spectrometer for the detection purpose. So this is the instrumentation of LCMS. So instrumentation of LCMS, in LCMS system, a device that connect the HPLC system with mass spectrometer is known as the interface. Means these two techniques, are interface. Means they are interfaced by a system or they are connected by a system known as a interface. Interface used in LCMS act as an ionization source that ionize the sample. The electrostatic lenses introduce the generated ions. The mass analyzer separates the ions according to mass to charge ratio. So the commonly see in LCMS, the interface are mainly the ionization technique. The interface used in LCMS are mainly the ionization technique. So different mass ionizer technique are used to convert that compound to ionized form. So different interfaces are used in LCMS are electrospray ionization technique, thermospray ionization technique, then atmospheric pressure chemical ionization, atmospheric pressure photoionization. So these different ionization techniques are used. So we see these techniques very shortly. So this electrospray ionization technique, it is a soft ionization technique. So in which they use they uses the electrical energy to assist the transfer of ions from solution into gas phase. They convert the ions from solution means they convert the solution into gaseous phase. Then the transfer of ionic species from solution into gas phase by different steps. First, they form the charged droplets, means by using a fine spray. So ESI, there is a ESI capillary. So this ESI capillary, they convert the liquid solution to a small charged droplets by spraying it. Then solvent evaporation is takes place. Then after solvent evaporation, the ion ejection from the highly charged droplets, means ions are ejected by because of the high voltage is applied. Okay, so it is a soft ionization technique. It is generally used for polar compound, least volatile and thermally unstable compound. Then next one technique is the most generally the in GCMS or in LCMS, the mostly used technique is atmospheric pressure chemical ionization technique. Atmospheric pressure chemical ionization technique, it is also a soft ionization method. It is similar to chemical ionization. It is similar to chemical ionization technique where primary ions are produced on solvent spray. So by using a capillary, okay, so fine droplets are produced and then by chemical ionization there is a production of primary ions. Then this APCI means atmospheric pressure chemical ionization. They vaporizes the solvent and sample molecule by spraying the sample solution into a heater using a N2 gas. So nitrogen gas is used for desolvation of that sample solution. The solvent then it is get ionized. So this nitrogen gas, they ionize this so sample molecules and then it is means they these ionized molecules or these ions are then detected by the according to their mass to charge ratio. So this is the atmospheric pressure chemical ionization. It is similar to chemical ionization technique, and it is mostly used technique in hyphenated system like LCMS and GCMS. So then next is after this ionization, means this mass ionizer, they convert the molecule into different ions, and then it is this the form ions. These ions are then detected by the mass analyzer. So the separated ions are then analyzed by using a mass analyzer. So different mass analyzer are used in GCMS and LCMS are quadrupole mass analyzer, time of flight mass analyzer, ion trap mass analyzer, and Fourier transfer ion cyclotron resonance analyzer. So in that, the mostly used analyzer in hyphenated techniques are quadrupole mass analyzer as well as time of flight mass analyzer. So quadrupole mass analyzer, it is the commonly used mass analyzer. It consists of two plane of parallel rods which are located between an ion sources and a detector. It consists of two plane of parallel rods which are located between an ion source and detector. So these opposite rods are charged with opposite charges, that is positive and or negative direct current potential. So these opposite rods are they are connected with opposite uh, current, opposite direct current, positive or negative direct current, and the radio frequency at the same time the radio frequency is parallel between this rod. So there is the oscillations of radio frequency alternating to current voltage is superimposed, means there is a oscillation of this DC potential and radio frequency. The oscillations are get superimposed, and this combination of DC and radio frequency this applied to rods, and the a stable mass to charge ions, they follow the path. They are trajectorized, means that ions are trajectorized which are having a stable mass to charge ratio. They are they transfer to a accelerated acceleration. They are transferred to acceleration, and then that mass to charge ratio are get detected by using the detector, and that ions are detected, and according to that ions the compound are detected. On the other hand, the unstable mass to charge ratio uh, means those are having unstable mass to charge ratio. They are discharged on the rods. They are discharged on the rods. They not follow the path. They not follow the path. Okay. So this is the quadrupole mass analyzer. Then next one mass analyzer is time of flight mass analyzer. Means in this time of flight mass analyzer, there is no requirement of magnetic field. There is no requirement of magnetic field. Just simple electrostatic and field is required. The ions are extracted from the source. Means the ions are extracted from the source and they are subjected to an accelerating voltage. Means towards the accelerating slits. They are subjected to accelerating slits. The time taken to travel the length of that, or the time to flight of that ions towards the detector, it is depends on their mass to charge ratio. Means those small ions, those are having a low mass, they are easily ejected, or they are easily fly, and they are detected by the detector. And those are with high mass, they are reached to detector with time interval. So the time taken to reach the detector is proportional to their mass of the ions. When the ions trend towards the detector, the lighter ions will strike the detector first, and then it is detected by the detector. So in the most useful mass analyzer in GCMS as well as LCMS are quadrupole mass analyzer technique and time of flight mass analyzer technique. So here we covered the two hyphenated techniques like GCMS, LCMS. The next hyphenated technique is LCNMR technique. Wait. So next hyphenated technique is LCNMR technique. So this LCNMR technique, it is the online coupling of high performance liquid chromatography to high resolution NMR spectrophotometer. So it offers a powerful tool for analyzing and characterizing the complex chemical mixture without the need of chemical separation. So this it is the online coupling of high performance liquid chromatography, that is HPLC, to a high resolution NMR spectrophotometer, and it is powerful tool for analyzing and characterizing the complex chemical mixture. So LCNMR, they promises to be a great value in analysis of complex mixture for all types of substances, as well as analysis of natural products, as well as analysis of drug metabolites. So these are the applications of LCNMR or HPLC NMR techniques. The firstly, this LCNMR technique means the experiment done with this LCNMR technique in 1970. Then there is a then instrumentation of LCNMR. This is the instrumentation of LCNMR technique. So LCNMR technique, they involve the HPLC system, then LCNMR interface, and NMR spectrophotometer. So it is totally a computerized technique. It is online coupling of HPLC with the NMR spectrophotometer. So it is totally a computerized system. So HPLC is coupled with the NMR with the LCNMR interfaces. So these coupling are of two types. See, this is also a block diagram of LCNMR hyphenated techniques. So LC in HPLC, what we required? So in HPLC we require the solvent reservoir, auto sampler, pump, column for the separation, and the detector. So a non-NMR detector are generally used. Then an LC-NMR interface. So these interfaces are of two types: direct coupling and indirect coupling. An NMR unit. So NMR unit or NMR spectrophotometer, they detect these compounds which are separated by using the HPLC. So this coupling, in the instrumentation of LC NMR, or the LC is coupled with the NMR by two methods: direct coupling and indirect coupling. So direct coupling include the direct flow of LC effluent into the NMR flow cell, and there is a continuous recording of spectra. So direct coupling, it includes the direct flow of LC effluent, means the effluent coming from the LC column or separated from the LC column, they directly enter into the NMR flow cell, and there is a continuous recording of spectra. So the requirement of this direct coupling, they require the post column splitter and wall switching interface. So the generally used wall switching interface in LCNMR is BNMI, that is Bruker NMR mass spectrophotometry interface is used. Then indirect coupling. So there is an intermediate storage loop which transfer the outlet of LC to NMR flow cell at specified time interval. Means in indirect coupling, there is a one storage loop in between the LC unit and NMR unit. So this here in this storage loop, the means we can the outlet means the effluent is goes to NMR at specified time interval. Also, this indirect coupling involves the SP unit, that is solid phase extraction unit. So this is about the LCNMR. So this LCNMR are work by different modes. That is continuous flow mode. That is, it is also called as a on flow mode. Then stop flow mode, time slices mode, peak parking mode, peak trapping mode. So this LCNMR is worked by different types of mode, like continuous flow mode. It is also called as a on flow mode. So effluent sampled in real time as flowing through the NMR detection coil, means the outlet of the LC detector is connected directly to the NMR probe, means there is no interface is required in this on flow mode. There is no interface is required for this on flow mode. Then stop flow mode. In stop flow mode also, the outlet of LC detector is connected to NMR probe. The LC detector is used to detect the peaks emitting from the column. So means the peaks are detected and the flow continues until the peak arrives in the NMR cell. So as this time the chromatography stops and the NMR experiment are performed. Once the NMR experiment are completed, then chromatography resumes until the next peak is found. Means in this stop flow method, so here the analysis means the separation is stopped for some interval. So here they required the LCNMR probe. Then it also required the interfaces. They also required the interfaces like BSPU interface, that is Bruker peak sampling unit is also required, and BSFU is also required. They require the interface for this. Then the next one, indirect technique, SP unit is used. SP principle is solid phase extraction. So it involves the separation of components of sample in solution through their selective interaction with the a solid adsorbent or solid sorbent. So specific hydrophobic organic functional moieties, they are interacted to that sorbent, and then they are interacted with and then they are separated, or they are connected to a interface for the separation. So this is about the LCNMR hyphenated techniques. Now LCIR. LCIR hyphenated techniques, it is least used hyphenated techniques. They are developed by coupling of liquid chromatography with the detector system, that is infrared spectrophotometer, or FTIR, that is Fourier transform infrared spectrophotometer. So it is also known as a LCIR or HPLCIR, because liquid chromatography, it is high performance liquid chromatography. While HPLC is one of the most powerful separation techniques are available today, and IR, it is the useful spectroscopic technique for identification of organic compound. So because in the mid-IR region, the structures of organic compound have many absorption bands, and that are characteristic of particular functional groups like OH group and COH group. The combination of HPLC and IR is difficult. The combination of HPLC and IR is difficult because of this mid-IR region. Means most of the organic compound, they are absorbed in this mid-IR region. So in this means the progress of this hyphenated techniques is extremely slow because of the hyphenated techniques. 237 absorption bands of the mobile phase solvent in the mid-IR region, and therefore it is not easy to hyphenate this LC with the IR. Therefore, to achieve the useful instrument that produces full mid-infrared spectra, the LCIR hyphenation process must remove the solvent without thermally damaging the analysis or overloading the vacuum system with effluent gas. So, means the solvent, most of the organic solvent, they produces their absorption spectra in mid-IR region, and because of that, it is not easy to hyphenate the LCIR. So we can hyphenate this process, that is LCIR hyphenation process. So we can remove the solvent by without damaging the analytes. And then in technology has incorporated two basic approaches based on interfaces applied in HPLC IR or HPLC FTIR. One is approach. One is flow cell approach and other one is solvent elimination approach. So according by using these two approach, that is flow cell approach and solvent elimination approach, this LCIR is easy to couple. It is easy to couple. Then the next one important hyphenated technique is CEMS. CEMS, it's a capillary electrophoresis is coupled with the mass spectrometry. CMS, which is the capillary electrophoresis, is coupled with the mass spectrometer. So capillary zone electrophoresis is widely recognized as a powerful analytical technique in its own right, known for its high precision efficiency, short analysis time, and low volume sample requirement. These characteristics made this capillary zone electrophoresis as a popular method for analyzing peptide mixture, protein and biotechnological processes.
कोण सांगितलंय नाही नाही तू डिप्लोमाचा आहे ना मला तरी म्हटलं मला नाव मी नाही मी डिग्रीच्या याच्यावर सांगितलं त्यांना विचारा ना तिथं अहो मी डिग्रीची त्यांचं कन्फ्युजन झालं असं
So, the capillary electrophoresis and mass spectrometry is a powerful separation and identification technique used for protein analysis and peptide analysis, as well as other biomolecular analysis. The principle of capillary electrophoresis mass spectrometry hyphenated technique in CEMS combine high efficient and high speed of capillary electrophoresis with high selective and high sensitive mass spectrometry. Means here high efficient and high speed of separation is coupled with high selective and high sensitive mass spectrophotometer. The separation first on the basis of charge to size ratio, because in capillary electrophoresis the compound are separated according to charge to size ratio, and then it is identified by mass spectrometry on the basis of their mass to charge ratio. So the separation or the identification in CEMS is based on separation according to charge to size ratio, and their identification is based on mass to charge ratio. The separating ion compounds are sampled by applying voltage to the sample. So there is separation of ionic component by applying the voltage to the sample. The ions will move through capillary at different rates due to their charge. So according to charge, they are to move through the capillary with when we apply the voltage. So positive charge is goes to the negative end, and negative charge ions are goes to the positive electrode. The separated sample is then sprayed into the mass which produces the spectra, and this from this spectra we identify the compound. So this is the principle of capillary electrophoresis and mass spectrometry technique. Now this is the instrumentation of this CEMS. So here, this is the capillary electrophoresis. The voltage is applied to the sample solution, and then here it is coupled with the mass spectrometry with the help of this ESI needle. That is ESI interface is used. That is electrospray ionization technique. ESI means electrospray ionization technique. They couple this capillary electrophoresis with the mass spectrometry. So this is the block diagram of instrumentation of CEMS. So different components which are important for the CEMS are the sample injector system, as well as the ionization technique is important. So sample injector system, the sample injection system in CMS are of two types. That is hydrodynamic injection system and electrokinetic injection system. So in hydrodynamic injection system, for loading the analyte, capillary placed into the sample vial. So in hydrodynamic injection system, the capillary for loading the analyte into the capillary is placed into the sample wire. This hydrodynamic injection is done by different ways. Means we apply the positive pressure to inlet and negative pressure to outlet. So sample inlet can be raised in relation to capillary outlet. So advantages of this hydrodynamic injection system is that it is unbiased to molecule with high or low electrophoretic mobility. Means in capillary electrophoresis, the molecules are separated according to their electrophoretic mobility. So here the sample injector system, it is unbiased to the molecule with high or low electrophoretic mobility. Then next one method of injection, sample injection, is electrokinetic injection. So in this method, high voltage is applied to sample solution and molecules are loaded to capillary by the electromigration and electroosmotic flow of the sample. The electrokinetic injection improves the sensitivity, whereas using low voltage means electrokinetic injection system, they are very sensitive compared to hydrodynamic injection system. But when the low voltage is applied, they take a longer injection time. Means they take a longer time for the injection when we apply the lower voltage. After the sample injector system, we interface or we couple this capillary electrophoresis with the mass spectrometry by interfacing system. So the mostly used interface in this CEMS is electrospray ionization technique. So electrospray ionization technique, it is an evaporative technique. So here the sample is introduced through capillary. At the tip of capillary, high voltage is applied. Then N2 gas is supplied as a nebulizing gas, which helps to spray the sample analyte. Then also N2 gas is supplied to desolvation of the sample. So it helps to vaporize the sample and they produces the molecular ion. Then these molecular ions generated, it is accelerated towards the accelerating chamber, and then it is detected according to their mass to charge ratio. So this is the electrospray ionization technique. Then other techniques are also used for ionization or for an interface, that is continuous flow fast atom bombardment technique, and also the multi-MS is also used. But the mostly used interface in CEMS, it is electrospray ionization technique. Then after this two-dimensional ionization technique, so or more than three hyphenated techniques. So the most this GCMS. So this GCMS technique is mostly used technique for high trace analysis, and it is powerful separation technique as well as powerful identification technique is used. GC-MS is also known as a GC tandem mass spectrometry. So analysis of trace analytes in a very complex sample. For example, environmental sample, food or biological sample, this GC-MS is used. Chromatographically, matrix peaks can be separated from the analyte peak using GC-GC. Means in GC-MS also GC-GC is coupled. So the matrix peaks are there separated to their analyte peaks, where two columns with different stationary phases used. Means how the GC-GC is coupled, so only two different columns are used. Two different columns with two different stationary phases are used. So these matrix peaks are separated from analyte peaks. Then tandem mass spectrometry, they uses the multiple stages within the mass spectrometer. So means two or three means two mass spectrometry are get coupled here. So it is called as a tandem mass spectrometry. And within this mass spectrometer, to increase the sensitivity of analyte by reducing the background from collating matrix peaks, means with this analyte peak, means generally this GC-MSMS technique is used to reduce the peak from the collating matrix. To reduce the peak from collating matrix. So GC-MSMS technique generally the means in GC-MSMS technique generally they use the triple quadrupole. This triple quadrupole system is used. Why they use this triple quadrupole system? Because the first Q is used for precursor selection. Then second Q, small q, is used as a collision cell. And third Q is used as a product ion mass analyzer. Means this triple quadrupole mass analyzer means their working is similar to quadrupole mass analyzer, but they are triply used. That is triple Q are used. So this triple Q means for detection of precursor ion, for detection of collisional ion, and for detection of product ion. So precursor ion means in fast mass means in GC-MSMS, in GC, two columns are get coupled. So in first mass analyzer, they select the ion is called means two MSMS are used. So in first mass analyzer, they select the ion is called as a precursor ion. Okay, and further it goes to next mass analyzer to produce their product ion. Okay, and so they are detected by third Q. So triple quadrupole mass analyzer is used in GC-MSMS technique. The next hyphenated techniques like GC-MSMS, it is LC-MSMS. So it combining the liquid chromatography with tandem mass spectrometry. So liquid chromatography generally it is HPLC system. Further improvement in sample identification and accurate quantification can be achieved by coupling of two mass analyzers that are operated in series. Means this tandem mass spectrometry, there is a coupling of two mass analyzer and they are operated in series. Triple quadrupole mass spectrometer is used. So I already explained triple quadrupole mass analyzer. So Q3 quadrupole mass analyzer is used, as well as quadrupole time of flight are these two mass analyzer are generally used in LC-MSMS as well as GC-MSMS technique. So the mass analyzer is also a derivatized. The mass analyzer is also a derivatized, that is a triple quadrupole mass analyzer and quadrupole time of flight mass analyzer. Then like this GC-MSMS, LC-MSMS, the other hyphenated techniques are means these hyphenated techniques are not commonly used, but they are having some certain applications. So therefore we have to cover. So LC-DAD or FLD. So it is for analyzing whole electrolyte or thermally sensitive samples. So this LC-DAD means liquid chromatography is coupled with the diode array detector It is useful for analyzing the electrolyte sample or thermally sensitive samples. So here they coupled means LC is coupled with DAD or LC is coupled with the fluorescence detector, that is FLD. So the mostly Agilent 1290 liquid chromatography, two detectors, that is DAD and FLD. Then auto sampler means it consists of 108 sample racks, and then these are the different columns are used, that is Zorbax extent C18 column, then HT 118 micron, then also Zorbax eclipse column. So these are the columns are used for LCDAD hybridization techniques. Then LCPDA ESI MS. So LCPDA means liquid chromatography is coupled with two spectroscopic techniques like PDA and mass, like PDA and mass. So the separation is done by liquid chromatography, that is high performance liquid chromatography, and they coupled with a photodiode array detector and as well as electrospray ionization technique of tandem mass spectroscopy. Means ESI is used as a ionizer. ESI is used as a ionizer in tandem mass spectrometry. So therefore, this technique is LCPDA ESI. So it is this method is developed for identification and characterization of phenolic compound from the crude extract. Then next one technique is GC API MSMS. So it is a powerful tool for the analysis of legacy POPs in human serum and plasma. POPs, that is the persistent organic pollutants. So it consists of 17 organochlorine, pesticides, 12 polychlorinated biphenyls, 9 polybrominated diphenyl ethers, and octachlorostyrene in human serum and plasma this is detected. It is detected by this GC API MSMS. So the separation is done by gas chromatography, and then this is automated pressure ionization technique with MSMS, that is tandem mass spectrometry. Then LC API MS. There is a combination of a reverse phase high HPLC, atmospheric pressure ionization, and mass spectrometry, or a tandem mass spectrometry, is an ideal for determining and characterizing the analyte in complex biological matrices by considering the three parameters by hydrophobicity, molecular weight, and molecular structure. So LC-API MS, so liquid chromatography, that is reverse phase high performance liquid chromatography, and these are the API. It is the ionization technique in tandem mass spectrometry. Then different applications of these hyphenated techniques. So different applications of these hyphenated different hyphenated techniques like LCMS, GCMS, LCIR, then GCIR, LCNMR, and all these techniques like GCMSMS, LCMSMS, LCPDA, GCAPI. So there are different applications of this hyphenated techniques. The first one application is food and beverage analysis. Means quantification of pollutants in drinking water and wastewater is identified, as well as quantification of pollutants in foods is identified by using this technique. Then medicine and pharmaceutical. So in pharmaceutical industry, for analytical research and development, means in pharmaceutical analysis for R&D, for QC, for QA, for production, and for the department of API, this technique is used. These hyphenated techniques are used. Then environmental analysis. Environmental analysis means to monitoring the contaminants in air, water, and soil is detected by this HPLC technique. Then oil and gas analysis. It is useful for natural gas testing, identification of unknown organic compound in hazardous waste dump, quantification of drug metabolites in urine, done for pharmacological and forensic use, then as well as pesticide and herbicide detection. Then it is also used for law enforcement for detection of illegal narcotic like opioids, cocaine, etc. in sports. So it is used in anti-doping analysis. This technique is used in anti-doping analysis in sports. Then it is also used in astrochemistry and geochemical research. Then it is also used in clinical toxicology, means toxins and venoms are identified using this technique. And the most important use of this hyphenated techniques in academic research, means in academic research there is analysis of new compounds or new synthesized compounds are done by using this hyphenated technique. So these are the applications of these hyphenated techniques. I have referred this some journals for this for collecting the data of hyphenated techniques. So these are the references. Also, I refer some books. So this is about the hyphenated technique. So I try to cover the different hyphenated techniques in my lecture. If any question, you please ask. Any question you ask on YouTube live.
I request Prajakta ma'am to give vote of thanks.
A very good afternoon to all. Myself, Prajakta Subramani, Assistant Professor of Shivajirao Sondhe College of Pharmacy, Asangam. It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. I would like to thank our speaker, Professor Manjusha Sanak ma'am, who honored this with inspirable thoughts. Ma'am delivered very knowledgeful lecture on different hyphenated techniques, how two techniques can be coupled and we can get accurate and efficient tool for organic compound, also how to identify complex mixture by the means of organic as well as inorganic compounds. Ma'am also presented different instrumentation and working very nicely about GCMS, LCMS, LCNMR, LCIR, CEMS, different mass analyzers. Ma'am also explained recent developments to avoid any problems regarding solvent system or regarding nature of compounds to be analyzed. Ma'am explained not only two coupling techniques, but also triple coupling techniques like LCMS-MS, LCPDA-ESI, GCAPI-MS-MS, which can be done by eliminating problem arises. It is very fruitful session with application. Ma'am gives very knowledgeful session. So thank you so much, ma'am. I would like to thank Principal of our college, Dr. Nitin Moire sir, and organizer Ganesh Mal Chaudhary sir, and all organizing committee, scientific committee for arranging FDP on such a applicative and informative sessions. Thanks to participants present over here and on YouTube live stream for making the time to be with us today and helping us make this session very successful. Thank you so much all.
Thank you all
Thank
for
you, ma'am.
You can leave the session. Wait. here we provide you the feedback. So all of you fill the feedback form.
हॅलो मॅडम, युट्यूबची लिंक बंद करू ना मंजुषा मॅडम?
Yes, sir. Close the link.
ओके ओके.